Yes. So the range is equals to 1.5 meters. The height is equals to 1.25 meters. Okay. Calculate the horizontal velocity as it leaves the table. Okay. So basically, you want to find out this V. Okay. So, hmm. So basically, they want me to find out the horizontal velocity V, right? So let's write down SUVAT. The problem is we only know R, which is 1.5 meters. We don't know what V is. We don't know what V is. We don't know what acceleration is, probably zero, and we don't know what time is. That's a problem. So like we have nothing. Okay, what do we do now? We don't have time either, but we can find out time, right? By using the vertical SUVAT, SUVAT. We know that acceleration is minus G, V is, I don't know, something. We know that vertical initial velocity is zero at this point, right? Because initially you have zero vertical velocity. So this is going to be zero. S, we know what S is. We know it's minus 1.25 meters. Okay. Because it's going down in this case. Okay. Now, can I find out time from this? Yes, I can. I can find out time because T is just going to be, uh, yes, V minus U over A is going to equal to T. V is 0 and U is, wait, no, we don't know what V is. That's a problem. We don't know what V is. Okay, crap. Hmm. But wait, we know what S is. Can we use S is equals to UT plus half AT square? I think so we can. Can we? Okay,
Yeah.
I think, yes, we can. Okay. So that means, do we know what S is? Yes, we do. It's minus 1.25 meters. Do we know what U is? It's just 0, so this just becomes 0. Plus 1 over 2 into minus 9.81 into T square. Into T square. That means minus 1.25 multiplied by 2 divide by minus 9.81. And then with the square root is going to give me T. Let's find out what T was. Stop me whenever you have a question, or I will just keep on going on and on and on till you are dead. Minus 1.25 into 2 divided by minus 9.81. And I have found out the time for the ball to fall down, 0.505 seconds. Okay. So now, since we know what time is, I think it's pretty easy to find out the range. We have found out what time is, 0.505 seconds. So R, or you just have to use V is equals to S over T, right? Average speed formula. And do we know what? Yes. So that's just going to be 1.5 divided by 0.505. And ta-da, we have the answer. 1.5 divided by 505. That is 2.97 meters per second. Okay, got it? That is the initial velocity. Yep, that's the initial horizontal velocity. So this is 2.97 meters per second. Okay. Now it says calculate the velocity just as it hits the floor. That's a very big problem. Just as it hits the floor. So basically, it's talking about this resultant velocity. So that means your resultant velocity at this point, and keep in mind that at this point, you would have a vertical velocity, horizontal velocity, and when you combine both of these, that's where you get your resultant velocity V. And that's basically what they're trying to find out, right? Because they're asking you to find out the velocity just as it hits the floor, right? They're not asking you to find out horizontal or vertical. So that means you have to do both of them. Any ideas how to solve this question? Yes, Ariz. What do you propose? We've done this question earlier. Very similar question. Yes, please let me know. Any ideas?
Yeah, I'm still thinking.
Hmm. You guys haven't been revising the stuff that we've been doing. It's all just a re-application of all of that stuff. We've done exactly this kind of question earlier as well. Although if we've done a difficult version of this question. Yes, Anya.
We're gonna find both like the vertical and horizontal like components over there, and then we're gonna find it.
Yes, absolutely. You are going to win a medal. So, if you want to find out the velocity at the end, first of all, you will have to find out what is the horizontal velocity at the end and what is the vertical velocity at the end. Okay. And then when you combine both of those vectors with Pythagoras, that's the total velocity at that point. That's it. The horizontal velocity is going to be the same, which is 2.97 meters per second, right? What is the vertical velocity going to be? We don't know. We don't know what Vy is going to be, but can we find that out? Right? So V S U V A T. What is S? That's just height vertical, 1.25. Do we know what U is? That's just zero at the top. V is exactly what we're trying to find out. V. A is minus G, and T, we've also found that out, which is 0.505 seconds. Okay. Can you find out what V is? Absolutely. It's just simply use V is equals to U plus AT. So V is just simply equals to minus 9.81 times 0.505 seconds. And tada, we have the velocity, minus 9.81 into 0.505, which is minus 4.95. So that means this is minus 4.95 meters per second. Now, can I use Pythagoras to find out the resultant velocity, right? If you'd like join these vectors head to tail, if this is Vy, if this is Vy, then that means when you join this head to this tail, this is going to give me the resultant vector. This was what? This was minus 4.95. So that means if you want to find out resultant velocity, right? Resultant velocity, all you do is you just do minus 4.45 squared plus 2.97 squared square root, and finally you have resultant velocity at that point. So that is going to be minus 4.45 squared plus 2.97 squared. So 5.35 is the answer. 5.35 meters per second is the answer. Now they also want you to find out the angle to the horizontal, right? So that means they're asking you like find out how much downwards is it going? Like how much is it towards the horizontal? What is the angle between the horizontal theta? Now, how do you find out the angle between the horizontal theta? That's just this angle. That is just this angle, right? So how can you find that out? You can just use tan theta or whatever theta you want. Tan theta is going to be what? Through proper brushing. Perpendicular over base. So that's just minus 4.45 divided by 2.97. And if you want to find out theta, you just do tan inverse. Okay.
Over here, can't we also use like cos theta, like
You
the
can use
resultant
whatever
was
you'd
tan
like. Yes.
2.97?
Yes, you can use sine theta, cos theta, perpendicular, whatever you want to find out. You can use sine rule, cos rule. You can use calculus, whatever you like to get the angle, you can do it. Okay. So, because you have all of the sides, right? You have this, and this. Generally, I prefer to not use the calculated side because we're often rounding off this and then we're rounding off this and then the resultant velocity is further rounded off. So that's why I just prefer to take the one that has not been calculated that much, right? 2.97, okay, we calculated that, right? We also calculated this. So like these ones are less rounded off than the resultant ones. So that's why I choose tan theta. Okay. Oh, where did it go? Okay. So theta. My, you don't need to use the sign, the minus sign, by the way. Won't make a difference. 56 degrees. 56.28. 56.28 or 56.3 is good. And that's how you calculate this, right? We've done this kind of question. We've done a much more difficult version of this question in our notes as well. Okay, sounds good. Let's move on. Question number 6. Question number 6 is what? So that determine the magnitude of the displacement PQ. Okay. Okay. So question 6 says it's a relatively difficult question. Not all of it, but one part is a little difficult. The rest is pretty easy. A ball is thrown from point P with an initial velocity 12 meters per second at 50 degree to the horizontal. Okay. The ball reaches maximum height at Q. Air resistance negligible. Calculate the horizontal component of U. What is U? Okay, so that's just horizontal component. So that's just, V cos theta, right? So that's just 12 cos 50. Pretty easy. 1 mark. Easiest 1 mark you'll ever get. 12 cos 50. 7.71. Okay. The vertical component. Oh, that's another free mark. V sine theta. 12 cos, 12 sine 50. This is them giving away Christmas presents. 12 sine. Sometimes they will not give you marks for doing stuff like this. And imagine, you just got 2 marks for doing this. Cambridge is just brutal. They love torturing you guys. 9.19. Okay. Show that the maximum height reached by the ball is 4.3. Oh, so easy. You want to find out that this h is supposed to be, we have to show that it's 4.3 meters. Pretty easy. So I think let's just use suvat because we want to find out height. H, you cannot use, keep in mind, you've got to show that the height is 4.3 meters. That means you can't use that in your formula. That just beats the point that we've got to show that our answer comes as this. You can't use 4.3 over here. Okay. Because that's like me telling you the answer is 5 and you say the answer is 5 because I told you. That's no answer. So S, we've got to find out. H, do we know what U is? We do. That's just 9.19 because we calculated V sine theta. Sorry, that's 9.19. What is V at the top? 0. A is minus G. T is, I don't know what that is. I can just use 2 is equals to V square minus U square. S is equals to 0 minus 9.1 square divided by 2 times minus 9.81. Let's see if that comes out as answer. If that comes out as our answer, that means we have won the war. 2 and 2 minus 9. If that doesn't, then that would be such a huge embarrassment. The answer is 4.3 meters. Yes. Okay. Determine the magnitude of the displacement PQ. PQ. Oh, now this is a tough one. Try to have a look at the question. Take 2 minutes to think about it. I'm going to ask every single one of you, how is it that we could solve this question? It's okay if you get it wrong. It's okay if you don't get it. Just try to think. The point is not to get the right answer. The point is for you to think. Use your brain cells, guys. Please. If you don't use your brain cells now, you will become retarded. Ugh. Yes. Anya, what do you think? How do you find out the magnitude of displacement PQ?
I think we're gonna find the horizontal distance.
Okay.
So
All of it?
basically,
Hmm.
no, half of it, like
Okay.
till two, basically.
Okay. So you're saying I find out this distance? Okay, but like what will that do?
I think, yeah, we
Then
find it using one of the equations.
can't we just use Pythagoras theorem to find out the distance between P to Q since it's a displacement?
Hmm. So you're saying that we should find out this triangle?
Yeah, like that.
Okay. Is that also what you're saying, Hania? We find out this
No,
distance? No, what are you saying?
I was
Hmm.
just saying like the horizontal one. That's it.
Okay. That's it? That's
Like that's what I figured out till now.
okay. Okay. Now they're asking you the displacement PQ, which means you have to find out the shortest distance from P to Q. You don't have to take this path. You have to take this path because that is the displacement, right? This is PQ. Now, if you want to find out this, right, that means you will have to find out this. You're absolutely right about this part as well. This is going to be range divided by 2, right? Because range is always for the entire journey. So this is just going to be R divided by 2. That means we'll first have to calculate what is half of the range. Okay, let's calculate half of the range. SUVAT. S in this case is R by 2. U in this case is actually just what? That's just 7.71. Also 7.71. 0. And do we know what the time is? No, we don't. We first have to calculate the time. Oh no. Crap, this is worth 4 marks. So, to find out time, we just use V sine theta over G. How did I get this? You can imagine I wrote all the S, U, V, A, T, and then I got equation of motion and then I substitute that. Or eventually, once you solve enough question, you will just memorize that the expression for time T, this is small t by the way, like for half of the journey to reach maximum height, you will see that V sine theta was what? That's just 9.91, 9.19 over 9.81. So what is that? 9.19 divided by 9.81, which is going to be 0.93, 0.94. Okay, now we also have time to reach half of the journey, which is 0.94 seconds. Okay, so V is equals to S over T, right? We want to find out S at the moment. Okay. Okay, we want to find out S. S in this case is, by the way, R over 2, right? So that's just going to be S is equals to V times T. And we want to find out half of the journey, right? Because I substituted 0.94 over here because this is the time taken to get from here to here. So that's why I'm also taking like half of the range. Okay. But wait, like we don't even need to do R over 2 because we want just this distance. We just want this distance. So like you can call it whatever you want. You don't even need to do R over 2 because we don't want the full range. We only want like half of it. Let's just call this, I don't know. Let's just call this, let's call it A. Okay. A for R is. So if you want to find out what RS is, RS is equals to V. What is V? 7.71. What was time? 0.94. RS is 0.93 into 7.71. Okay. The value of RS is 7.22 meters. So this is, whatever this is, this is 7.22 meters. Okay. And do you know what this is? You do. Do you see that now you've formed a triangle, a right triangle? And the right triangle where the side A is 7.22, the horizontal is 7.22, height is 4.3, and you can find out PQ from Pythagoras again. Pythagoras is our best friend for projectile motion. PQ is equals to this value. 4.3 squared plus 7 point, I'm using Pythagoras, is 8.4, ladies and gentlemen. And that's how you solve this question. Yes. Yes, Kaima. Yes, Kaima, were you able to follow through? Did you get how we found out PQ or no?
Yeah.
Yes, did you get how we figured out this range? 7.22.
Yes.
Yes, okay. We already had like the height. We figured it out earlier. Yes, Aris, did that make sense?
Yeah, so just let me.
Hmm.
Can I just read it again? Just one
Okay,
second.
sure. Yes, Anya, did that make sense?
Yes, I got it.
Okay. Last question remaining for projectile motion.
Okay. Yeah, I understood it. We can go to the next.
Yes, okay. Perfect. Last question. Finally, we're going to kill this chapter. Question number 10. A stone is thrown vertically upwards. The variation with time t of the displacement of s of the stone is shown. Okay, so this is a graph of displacement time. Keep in mind, this is displacement time. This is displacement time. Very important. Okay, okay. Can you try to figure out what this graph is telling me? Take 2 minutes and try to just read it and tell me what this graph is telling me. What story is it telling me?
Uh,
Hmm.
like like when he throws it vertically upwards, the displacement
Okay.
it like goes upwards, but then slowly it starts moving downwards,
Okay.
and like it reaches at one point where the displacement, where like the
Hmm.
object stops moving, which is like that peak,
Mm-hmm.
and then after that it just starts falling back down, right?
Okay. So like what's at this point? What is this point? Like at zero? Is that when it
At this
stops moving?
point, at this point, does it like move further down than what was the starting point?
Hmm. Okay, okay. What do you think, Kaima? What does this graph tell me? Any idea? It's a displacement time graph.
The speed decreases until it's like stationary.
Hmm. What about this, like this up till here? It's a displacement time graph. Like, what does this peak indicate? What do you think? What, Kaima, do you remember? Oh, one thing else, yes. Do you remember what the slope of a displacement time graph told me? What was it? Do you remember? Yes, Kaima. Do you remember what the slope of a distance time graph was? Think, think, think. Very, very important piece of the puzzle for kinematics. If you do not remember what the slope of a distance time graph is, you will be jailed. Not even Donald Trump can save you if you do not remember this. What was it? Don't remember, Kaima?
And
No?
is it the speed
It is the
of the engine?
speed. It is the speed, absolutely. The slope of a distance time graph is going to tell me speed. That's a very, very important piece of information. That's like one of the most basic things with kinematics. What was I saying? Kaima, you need to be spending a little more time revising what we did earlier because if you forget the pieces, it's kind of like making a house of cards. Have you ever seen a house of cards? You know, you have like multiple cards which are like joining like this, and you keep putting cards on top, and then you make another card, and then you put another card, and just keep on doing that till it falls. Physics is exactly like that. If you forget one of the pieces, it's kind of like if you forget this is like playing Jenga, everything will come down falling. And the speed and motion part of physics is like the very few basic cards, right? So if you like don't have the foundations right, your card is going to fall pretty quickly. Okay, that's why spend a little more time revising. The basic kinematics. Since you have a Wednesday test on Wednesday as well, I would recommend that you go over everything again. And one other thing for all of you, make a cheat sheet for like everything that you've done so far. So like make a separate cheat sheet for in fact, show it to you. Let me show it to you. This is one I made for IGCSE. Although it's basically the same stuff. So it's a cheat sheet like this, where you have like all distance, time, the definitions, velocity, time definitions. You see all of the very basic graphs and what do the gradients mean, what do the shapes mean, what does the slope mean, and then what does the area under the graph mean. This is very, very basic stuff for kinematics. If you do not remember this, it'll cause a huge problem, and you will eventually start hating physics, and you will say physics is shit, please don't teach me physics. Okay, so we don't want that because you've already started physics. Okay. Yes, Kalima, make sense? Oh no. Would you like to disagree? Hmm. So what was I saying? Oh yes. So slope of uh what was it? Displacement time. In this case, it's displacement. So this is just going to be velocity, right? So the slope is going to tell me velocity. So that means if you make a tangent at different points, this is going to tell me the velocity. Velocity. If I make a slope at this point, right? This gradient is zero, which means the speed at this point is zero. The speed at this is positive velocity. The speed over here is, this is the tangent, right? So the tangent is negative, which means the speed is also negative, right? It's falling down. So basically what happens is in this graph, if you read it right, from zero to the top, okay, this is the displacement decreasing. So like if I were to make a diagram, okay, this is like the starting position of the ball. This is the starting position of the ball. Okay. Oh, okay. So initially what happens is that you start from zero, s is equals to zero, okay? Then you throw the ball upwards and it reaches up till this point. So let's call this S max. This is S max, okay? Then it starts to come down back to zero. Now it's at this point and then it starts to come back to zero. So like at this point, you are back at starting, back at starting point, back at starting point. And do you notice that you have a negative slope for this entire curve? Negative slope means negative velocity, which means at this point, the ball had a downward velocity, right? Negative velocity. Okay. Then at this point, you're back at where you started. And once this graph starts to go in the negative axis, this means now you are actually even lower than you were earlier, right? So this is basically what negative displacement is implying, that you're now even lower than where you already started. Okay. Yes, Hania, does that make sense?
Yeah.
Okay. Yes, Kaima, does that make sense or no? Are you sure it does? If it doesn't, then they can let me know.
Yeah.
Yes. Okay.
Yes.
Okay. Use figure 2.1 to describe without calculation the speed of the stone from t is equals to 0 to t is equals to 3. That's basically just trying to describe the gradients. You don't need to calculate anything. You know that the slopes are changing. So from 0 to what time is this? Is that what? What time is this? It's physics time. Where is the slope 0? I think it's at this point. This is 1
Is
point.
there 1.5?
No,
Wait, no,
because
no.
this is 1.5, I think. Not sure though. This is like, where is 1.5 though? So 10 and 10. Yep, this is 1.5. So this is 1.5, then this must be, I think this is even half of that. So 1, 2, 3, 4, 5, 1, 2, 3, 4,
0.25.
5, 1.25. Okay. So from t is equals to 0 to t is equals to 1.25. Be very precise. You start with, do you see that you start off with the maximum speed and then your slope starts to fall? And slope starting to fall means that your speed starts to decrease. Speed decreases till speed is equals to 0 at 1.25 seconds. Okay. Then at 1.25 second speed, or you could say speed switches downwards. Speed switches downwards and keeps increasing and keeps increasing till 3 seconds. Because do you see that the slope over here is pretty low, then the slope keeps on increasing, increasing, and increasing. So that means the speed has been increasing, but because you have a negative slope, that means you have a downward velocity. Okay, but he's asking for
Yeah.
the speed. Yes.
But how does it show that like it ends at 3 seconds? Like how does it show that it stops at 3 seconds?
Oh, it doesn't stop. That's just where the graph stops.
Oh, okay.
Till 3 seconds on graph. It doesn't stop.
Yeah.
It obviously it probably keeps on moving, but that's just where the graph stops. Okay. Uh, Assume air resistance is negligible, and therefore the stone has constant acceleration. Okay. Calculate for the stone the speed at 3 seconds. That's a very difficult question. So they just want the speed at this time. That's a very big question. Hmm. Okay. How do you want to solve this? How do you calculate the speed at this point? Good question. Yes, Aris. This one's for you. This is my gift to you. Oh, how do you find out the speed at that point?
Can we take like a point between
Hmm.
like when when like at coordinates
Hmm.
2.5 and I think it's 2.5, 2.5 and 0, and then like the other point is uh 3 and no, but then we don't have any like
Hmm.
coordinates for
Exactly.
displacement.
Exactly. We don't. That's the problem. We do not have any displacement values. But you don't need displacement values. Think about it. All you need is time. Think about it. Do we know that v is just simply equal to
Oh
u
yeah,
plus
and the
at?
acceleration is also constant, so
Exactly. Do we know that v is equal to u
it's
plus at? What was the speed at
yeah,
this point?
it was 0.
Exactly. Do we have a reference point now that v is 0 at this point? And can we choose this time as our falling time, right? Right? If your speed was 0 at this point, can we take this 0 as a reference point? And after this, the speed keeps increasing, increasing, increasing. And can we find out the speed at 3 seconds at that point? Can we?
Yeah,
Yes, we
yeah,
absolutely can. So that's it. That's the question is solved. Pretty easy, you know? So what was u at that point? That was just 0 into minus
minus
9.81
9.81
times
into
t.
3.
Now we've got to find out t. So that's just 1.25 till 3, right?
Yeah,
So that's just going to be 1.75. Let's just write it as 3 minus 1.25 seconds.
but didn't they
Okay.
say the speed at 3 seconds?
What do you say?
They said the speed, calculate the speed at 3 seconds. So won't we just use 3?
Uh, 3.
Oh no, no.
Wait. No, then then, so if you want to use 3 as the time in your formula, then you will have to take your initial velocity as this point. But we don't know what the initial velocity is at that point, right? So that's why we're taking this point, because we know that from the top, or at when, u is equals to 0, we know the time taken for that journey. And we also know that the initial velocity for this point was as well. So if you want to use 3 over here, you can, but you will then have to change your initial velocity as well, right? Because if you take
Yeah.
the time of total 3 seconds, then you have to take the entire journey. Okay. But if you want to take the journey from this part to this part, you can easily take this as your reference point as 0, which will make your life much easier. Okay. So that's why. So minus 9.81 times whatever that is. But let me calculate it. But that was pretty easy. That was like a lot of, that was pretty little effort. We won. Minus 9.81 into 1.75. It is 17.17. Okay. Now calculate the distance traveled from t is equals to 0 to 3 seconds. They're asking you distance. Distance traveled. Okay. How do you calculate the distance traveled? Big problem. Total distance traveled. So that means all of this and then all of this distance as well. So you add both of the distances. How do you do that? It just happened. How do you find out the distance? Yes, guys. Any idea? Yes,
Won't
Anya.
distance,
What are you
won't
saying, Aris?
distance, won't distance just be equal to displacement as it's thrown vertically upwards? So
No, the distance will not be equal to displacement for the entire journey, because do you see that you first travel upwards, which is like positive displacement, and then you travel backwards as well.
oh yeah, because displacement is a vector quantity.
Yes.
So
So if you want to find out the distance, you have to add up all of the distance. So that means the distance that you went upwards and then the distance that you went downwards as well. And keep in mind, if you're talking about distance, which means you first calculate the distance to go from here to here. Okay. Then you calculate the distance to come back. And then you calculate the distance to go even downwards. So that's a very, it's a complicated process where you have to make sure you're counting everything. But for displacement, you can just count all of this as 0. Why? Because the net displacement up till your starting point is just 0. You came right back where you started. So you can just ignore all of this and you just have to calculate this one. Okay. Now, I am going to leave both of these questions for you. Part 2 and part 3. Okay. It's a total of 5 marks and you've got to calculate it yourself because you guys haven't been doing the questions. So I'm going to leave this question to you and I want it in 10 minutes. Okay. You have 10 minutes for this question. I think I have uploaded this. Wait, let me send it to you. I want you to look at this question, read it yourself, and see how you can solve it. If I'm doing all of the questions that I am the one that's practicing, I don't want to give my levels again. You do. I have sent the link for this note in the group. And I leave the last 2 parts to you. And I want the answer in 10 minutes. Okay? Yes, Anya, will you do it?
Yeah, I'll try.
Okay. Kaima, I am waiting. Doesn't matter if it's right, doesn't matter if it's wrong. Try. Whatever the answer is, that's okay. No answer is the worst. Wrong answer is absolutely wonderful. It's the best. But no answer is horrible. No answer deserves to be trolled. Okay. Yes, Ariz. I am waiting. Will you do it?
Yeah, I'll do it.
Okay, perfect. So I've sent it. You will open the note. You will open the note. You will look at the diagram. You will look at the calculation. What could be possible? You can try to think. You can revise the formula. You can think what could be wrong, what could not be wrong, and then calculate the distance. Okay. I will then see you on Wednesday when you will have a test of projectile motion and kinematics. Okay. Hmm. Sounds good. That'll be all for today, and I'll see you on Wednesday. Take care. Allah Hafiz.
Allah.